Okay, so just when you thought I couldn't throw enough stuff at you about the unit circle, we're going to go ahead and proceed to the next level. So hopefully you understood everything I said before. That'll give you a good foundation for what we're going to get into now. But you can still understand what I'm saying, but it's pretty crucial that you understand your trig functions, sine, cosine, and tangent. So if you remember the acronym, so, ka, TOA, that's going to be helpful to remember here. If you don't know what these are, if you don't know sine, cosine, tangent, and also cotangent, secant, cosecant, watch my videos on that, okay? But otherwise, this acronym is going to be very helpful. So we're going to start off by basically evaluating angles in the unit circle, right? So if I said sine of 0 degrees, or cosine of 0 degrees, or tangent of 45 degrees, could you tell me what those values are, right? That's what you're going to learn right now, okay? So we're going to start off by, again, making a right triangle, right? So here, I'm just going to happen to use this point here again, but it doesn't really matter. You can use any of these points. The crucial, you just got to make sure it's a right triangle. We're going to label this theta. It's not necessarily 45, it's just some angle, okay? But this radius is still going to be 1. We're still in the unit circle, that's fine, but you can consider it the radius, right? So this is still the x value, and this is still the y value, right? We've got a right triangle, the radius is the hypotenuse, this is the leg x, this is the leg y, right? So let's say we want to do cosine. Let's start with cosine. So if I'm going to find cosine of theta in this triangle, right? Well, cosine of theta, cosine is adjacent over hypotenuse. So the adjacent side is this side x, and the hypotenuse is r, right? So adjacent over hypotenuse, x over r, right? So cosine of theta in this triangle is going to be x over r, right? So what about sine of theta? So sine of theta, sine is opposite over hypotenuse. So sine of theta is opposite the y over the hypotenuse, which is the radius, right? Opposite over hypotenuse. Opposite y, hypotenuse r, sine theta equals y over r. Okay? So finally we do tangent. Tangent of theta is equal to opposite, tangent is opposite over adjacent, so tangent opposite y, adjacent x, so tangent theta equals y over x because that's the opposite side, that's the adjacent side, right? So in this triangle, and this could be pretty much in any quadrant, doesn't really matter, right? We have cosine theta equals x over r, sine of theta equals y over r, tangent theta equals y over x, right? But if we know we're in the unit circle, then we know the radius is 1. So I could replace this r with what? 1. And x over 1, of course, is what? Just x, right? So if you know you're in the unit circle, then you know cosine of theta of that angle is going to equal whatever the x value is in the unit circle. So cosine of theta equals that x value, right? We can do the same thing here, right? So r is still going to be 1. So y over 1 is going to equal y. So as long as you know you're in the unit circle, so sine of theta is going to equal the y value, right? But this shortcut only works for the unit circle. But these equations here work regardless of whether you're in the unit circle or not. But if you know you're in the unit circle, then you can simplify this by putting 1 here, and then you get this, right? But if you're not in the unit circle, then you can't use these shortcuts. And cosine of theta is not equal x, sine of theta is not equal y. That's only true if you know you're in the unit circle. But you can use these right here for any circle, unit circle or not, right? But these here only work for the unit circle. So if you notice tangent theta doesn't have r, so this one you can use, again, any circle, unit circle or not, doesn't matter because there's no radius here anyway, right? So let's do an example. So cosine of 0 degrees. What is 0 degrees? 0 degrees is right here. So cosine of 0 degrees is equal to what? The x value here. What's the x value here? 1. So cosine of 0 degrees is equal to 1, right? Okay. What about cosine of pi over 2? Where's pi over 2? Pi over 2 is here. What's the x value here? 0. So cosine of pi over 2 is equal to the x value. Cosine of pi over 2 equals 0. Cosine of 0 is equal to 1. Cosine of pi over 2 is equal to 0, right? How about cosine of pi? Where's pi? Pi is here. What's the x value? Negative 1. Cosine of pi is equal to negative 1. Cosine of 270. Cosine of 270 equals 0, right? Very simple, right? So let's do a slightly harder one. How about cosine of 45? 45 is here. What's the x value? Rad 2 over 2. Cosine of 45 equals rad 2 over 2. Right? How about cosine of 2 pi over 3? Cosine of 2 pi over 3. 2 pi over 3 is here. The x value would be negative 1/2. So cosine of 2 pi over 3 should be equal to negative 1/2. Right? So what if I said cosine of 5 pi over 4? That's going to be negative rad 2 over 2. Right? Okay, so let's try sine. Right? So what if I said sine of 0? Sine of 0, so sine of 0 is going to equal the y value in the unit circle. So sine of 0 degrees is equal to what? Well, the y value here is 0, so sine of 0 equals 0, right? Don't get these mixed up, so make sure you understand these are angles here, and these are the coordinates, okay? So these are the coordinates, this is not an angle. This is an angle, these are not coordinates, right? Coordinates, angles, coordinates, angles, angles, coordinates, okay? Don't get it mixed up, right? So what if I said sine of pi over 2? Sine of pi over 2 is equal to 1, because sine refers to the y value, right? What about sine of pi? Sine of pi equals 0. Sine of 270. Sine of 270 equals negative 1, because it's the y value, right? How about sine of 3 pi over 4? Sine of 3 pi over 4 is rad 2 over 2. How about sine of negative pi over 6? Negative pi over 6 is going to be right here. So negative pi over 6 is the same as coterminal with positive 11 pi over 6. So sine of negative pi over 6, sine of negative pi over 6 is going to be negative 1/2, because the y value here is going to be negative 1/2, right? Okay, so hopefully the cosine and the sine make sense to you now, right? So what about tangent? So if we did tangent of 0. So tangent is going to be the y divided by the x. So it's a little harder because you have to do get a hold of two values and divide them actually, right? So tangent of 0 is going to be the y value divided by the x value. So tangent of 0 is going to equal 0 divided by 1. 0 divided by 1 is 0. So tangent of 0 equals 0, right? How about tangent of pi over 2? Tangent of pi over 2 equals 1 divided by 0. Well, hopefully you know you can't divide by 0. It's going to be undefined. So tangent of pi over 2 is actually undefined. You can't do it, okay? What about tangent of pi? Tangent of pi is going to be 0 divided by negative 1. So 0 divided by negative 1 is 0. So tangent of pi equals 0, right? Tangent of 270. Tangent of 270 is negative 1 over 0. Same as tangent of pi over 2, undefined here, undefined here. So tangent of 270 is going to be undefined. You can't do it, okay? So how about we do tangent of 45, right? So this is a little more interesting. You want to notice that the x and y values are the same. So tangent of 45 is going to be rad 2 over 2 divided by rad 2 over 2. And hopefully you understand that that's going to be 1 because it's like 3 divided by 3 is 1. 7 divided by 7 is 1. So if your numerator and denominator are the same in a fraction, then the answer is 1, right? So rad 2 over 2 divided by rad 2 over 2, you're dividing the same number, that's equal to 1. So tangent of 45 is equal to 1, right? So what about tangent of 3 pi over 4? Again, it's going to be the y value divided by the x value. But again, these two values are the same except for one's positive, one's negative. So this divided by this, hopefully you understand, is going to be negative 1. So tangent of 3 pi over 4 is equal to negative 1, right? So how about tangent of 225? Well, coordinates here are going to be negative, negative. So tangent of 225 is going to be positive 1, right? Okay, because here's negative rad 2 over 2 comma negative rad 2 over 2, right? You divide those two, you get positive 1. How about tangent of 7 pi over 4? Tangent of 7 pi over 4 is going to be negative 1 because it's going to be positive x and negative y, right? Okay, so that one's pretty simple. So let's do a harder one. So how about tangent of 30? So tangent of 30 is going to be 1/2 divided by rad 3 over 2. But you want to notice that the denominators are the same, so if you understand how to divide fractions when the denominators are the same, the denominators essentially cancel out. So 1/2 divided rad 3 over 2 is basically the same as 1 over rad 3. So it's kind of like you kind of ignore the denominators when you're doing this division, right? So tangent of 30 degrees is going to be 1 over rad 3, right? And 1 over rad 3, if you rationalize, is going to equal rad 3 over 3. So tangent of pi over 6, or tangent of 30, is equal to rad 3 over 3, right? So how about tangent of pi over 3? Tangent of pi over 3, again, y over x, so rad 3 over 2 divided by 1/2, but again, you can kind of just cancel out the denominator. So basically it's rad 3 over 1. Rad 3 over 1, of course, is just rad 3. So tangent of pi over 3 is equal to rad 3, right? Okay, so let's do maybe a harder one. So let's try tangent of 5 pi over 6. So tangent of 5 pi over 6 is going to be the y divided by the x. So hopefully you figured out that's going to be negative 1 over rad 3, which is basically the same as negative rad 3 over 3, if you rationalize that. Okay? So what about tangent of, let's see, tangent of 4 pi over 3. So tangent of 4 pi over 3, so that's going to be using these values here. So tangent of 4 pi over 3 is going to be positive rad 3 because basically both of these values are negative, right? So this guy divided by this guy is going to be positive rad 3. So tangent of 240 or 4 pi over 3 should be positive rad 3. Okay, hopefully I did that right. Okay, so then we're going to go into cotangent, secant, and cosecant. So hopefully you understood all those so far.